Hello students, welcome to the next lecture on conventional manufacturing processes, and in this lecture we will discuss about the milling machine numerical. So here the data is given for a particular example, and we know that to solve any of the example, first one must need to understand what is asked in the particular example and what is the given data. So here the final requirement is to calculate the time required for milling the slot. So our main requirement is to find the machining time, and the equation we know that is the L divided by Fn. So for this we need to find the distance traveled by the milling cutter, then we need to find the feed, and then the revolution per minute RPM. So now for this we will use the given data. Now we know that the data given over here, that is the length given, that is the 300 mm, and the diameter of the cutter that is given is the 100 mm, width is given as the 30 mm, and the teeth on the cutter that are given, that are the 20. Now the depth of cut is also given, and that is the 5 mm. Now feed is also given, that is 0.1 mm, and the cutting speed given as 35 meter per minute, and over travel distance is 5 mm. Now the approach distance is not given, so we need to find this to get the overall distance traveled by the cutter. Now for that we know that in this particular case the approach distance is calculated using the equation 1/2 in bracket d minus under root d square minus small d square. We know that the capital D, that is the diameter of the cutter, and the small d, that is the depth required. So here it is given as the 30, or we can say it as the this capital D and small d from given data. What are the values for that? So capital D, that is the 100 mm, and here this D is nothing but the width of the cutter. So we can write B as the 30 mm. So after placing the value, we will get 100 minus 100 square minus 30 square. So after solving this equation, we will get the value of AP as 2.3 mm. So now we know that overall distance traveled by the tool, that is the length of the workpiece plus approach plus overall distance traveled. So that is 300 plus approach that we got is 2.3, and the overall distance traveled, that is the 5 mm. So this value will be 307.3 mm. Now we have the value of L, we have the value of F also. Now to find the value of N, what we will do is we will use the equation V, that is equal to pi dN divided by 1000. Now you just remember these two values. We got the value of L as 307.3 mm and the feed as the 0.1 mm. Now we will find the value of N from this equation. So now we will find the required RPM using the equation pi dN divided by 1000. Now we know that N, that is equal to velocity given is 35 divided by 1000, pi into diameter is 100. So the value of N we will get, that is 111.46 RPM. Now we have the value of L also, that is 307.3 mm, that we already find, and the feed that is given is 0.1 mm per tooth, and the tooth number of tooth given are 20, right? So using all these value, we will find the machining time required L divided by Fn. So here L is 307.3 divided by feed is 0.1 into 20, and the n that we have obtained, that is 111.46. So after solving these values, we will find the machining time required, that is 1.3791 minute. So this is how we will find the machining time required. So here just one need to understand that if the approach data is not given, approach travel data is not given, then one must need to find the approach travel data from the given milling tool details. So if the side milling data is available, face milling data is available, or the end milling data is available, based on that one can use the required equation for the approach travel calculation. So I hope you understand how to find the machining time calculation for the milling cutter geometry and the milling cutting operations. So looking forward to see you all in our next lecture. Up to then, thank you.